When I was a high school chemistry student, they told us it wasn't possible to see single molecules. But you can see them, and they're beautiful. And as you are watching them blink and flicker, they almost seem alive. My lab, the Goldsmith lab, at the University of Wisconsin Madison, builds specialized microscopes that allow us to observe the behavior of individual molecules. We want to make molecular movies of chemistry as it happens.
There's a really simple way to understand why it's worth making your measurement on a single molecule. Let me start by playing a terrible sound. Okay, now let me unscramble that sound.
There's antimony, arsenic, aluminum, selenium, and hydrogen, and oxygen, and nitrogen, and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium.
What I did was take the Element Song by Tom Lehrer, a song that is very popular amongst chemists, and I took Tom Lehrer and I cloned him 20 times. And then I took each of those Tom Lehrers and I had them start singing at a different start time. And then I added them all back together to make that terrible sound you heard. Okay? And what did you hear, right? You heard white noise. You heard terrible white noise, right? You definitely couldn't hear Tom Lehrer singing.
Molecules also have songs to sing, although they're not singing with sounds, they're singing with light, photons. And even 20 molecules is enough to prevent us from perceiving that song, and with Avogadro's number of molecules, it's not even close. But by looking at one molecule at a time, now you can start seeing what they're doing and start making a molecular movie. There are some places where it's really hard to shoot a molecular movie, and those are the places my lab is working because we want to be able to make those movies. For example, looking at chemical reactions in solvents outside of water is hard because you need new fluorescent molecules. So we're inventing new molecular movie stars. Looking at proteins involved in neurodegenerative diseases like Alzheimer's disease is also hard because the molecular movie stars are very easy to perturb. And so we need to find ways so that the molecules don't know they're being filmed. Another example is looking at molecules that do not emit photons. My lab is pioneering the use of microstructures called optical resonators that sculpt the way that light interacts with molecules. In this way, we're taking ideas that were born in physics and engineering for telecommunications technologies and applying them to chemistry. We want to be able to take molecular movies of the most important processes in chemistry and biochemistry.
So cool.